Thank you very much, Stephen. Good morning, good afternoon, good evening, everyone. I am Yasunori Akashi from the Department of Architecture at the University of Tokyo. I would like to talk briefly Japan's activities and the challenges related to the Annex 81. Yes, firstly, I would like to explain Japanese situation. There are three main motivations for Japan's participation in Annex 81. First one is that decarbonization of buildings has become urgent issue in Japan also. Second one is that data-driven operation in existing buildings is very, very important for the decarbonization, but very few energy-saving measures have been taken for the existing buildings, unlike new buildings. Third one is that the topic of Annex 81 is deeply related to the creation of new value and business in the field of building services. In Japan, it is necessary to set up a domestic committee to participate in Annex. So we organize the domestic committee as shown here. We are discussing about data-driven smart buildings with about 20 members of the committee, which consists of 13 companies, one non-profit organization, and 2 universities. In the main meeting of Annex 81, we provided 2 examples in Japan on data-driven operations in building systems. The first example is commissioning of Kyoto Station building. As you know, the Kyoto Station building is very big buildings and complex buildings with the total floor of about 230,000 square meters, which was built in 1997. In 2010, the large-scale waterside system retrofit project began, and the commissioning process was fully applied to the project. And this project is the first case of business-based commissioning implementation with commissioning fees in Japan. The energy saving of 60% targeted in the owner's project requirement has been achieved, of which 8% reduction also achieved using the measured data of energy management system through the functional performance test and operational optimization during the first 3 years after the completion. For the aspect of simulation and data-driven operation in the system, they developed the detailed simulation with automatic controls, as shown here. And also they developed the applications for the optimal control logic of the chillers using the simulation, as shown right side. And this application and the data of energy management system optimize the actual operation. As a result, they can get the additional 8% energy savings in operation phase. Second example is about automated fault detection and diagnosis. The project is conducted in HVAC waterside system of a semiconductor plant. This is the project in my laboratory. So we study about this with some companies. As you know, conventional manual fault detection and diagnosis and optimization are extremely inefficient. So they are rarely implemented, including in general building systems. However, as Stephen said just now, some reports indicate that the fault detection and diagnosis and operational optimization can reduce building energy consumption of around 10 to 30%. I think the number is very big and meaningful toward the decarbonization of the buildings in the operation phase. As the same, for the aspects of simulation and data-driven operation in this example, we developed the detailed simulation with automatic controls originally, and also developed applications for automated fault detection and diagnosis using the simulation and machine learning. Now, these applications are being demonstrated in the actual system to verify the effectiveness of the method. The method is that many faulty behavior generated by the simulation, and the convolution neural network learns the future of the faults and diagnoses the measured data. This is a graph, the trend graph of the possibility of the fault. That the differences of the color shows the a kind of fault. Now this project is going to show the effectiveness. Okay, this is the last slide, and I summarized what we learned from these examples and Annex 81 at this stage. First one is that data and applications can improve building energy performance in the operation phase. Second one is that various data and applications need to be utilized in buildings on a plug and play basis. I think, in other words, it will upgrade building energy performance according to the building usage. However, in Japan, there is very little use of the data, such data and applications. I think the construction industry in Japan is just a tipping point, but it is not active yet. For instance, as I mentioned here, an open platform is still not used in most buildings in Japan. And a cloud energy management system is used in each example, which I talked now, but it doesn't have mechanism to efficiently manage large amount of data, such as a graph database and metadata information. Therefore, I think important point for promoting decarbonization of existing buildings is that developing data-driven system that can be installed easily during retrofit or normal time. Making building owners and occupants understand the value of installing the technologies for the data-driven smartification. And human resource development is also very important for system integration and application development. That's all from me. Thank you very much for your attention.